Audio Jungle. Audio Jungle.
Today we'll talk about the formulation of aerodynamic center and center of pressure. I mean, how to find the location, how to find the location of aerodynamic center as well as center of pressure. Separately, we have to calculate, and also we have to develop the relationship between the aerodynamic center and center of pressure. Just like center of pressure, if it is known, then aerodynamic center and vice versa. That is important. Sometimes question they are asking based on the aerodynamic center and center of pressure. Okay, it's very special actually. Now one by one we'll see. So first what we have here, see everybody, we have a check aerodynamic center. Aerodynamic center, right? If you see the aerodynamic center, it is nothing but AC aerodynamic center. But if you calculate the position of the aerodynamic center, it will be denoted by XAC. XAC, that is the location of aerodynamic center. From leading edge, right? Now see the 3D view of the wing here, check, right? This is the 3D wing. Okay, basically this length you are measuring from the leading edge to trailing edge. This is what leading edge and this is what trailing edge. We suppose that flow is what coming from this side, right? And this length called a span length, right? This is called this side, it is called root, because this section is what connected with the fuselage, so it is called root, and here this one is called tip. These are the name you need to remember. If you cut the cross section, if you cut the cross section here, if you cut the cross section, so that will be 3D wing. That will be the basically airfoil, which is called 2D wing or infinite wing. This is the airfoil, check. This is what? Airfoil. Airfoil. Because airfoil is called 2D wing, also called infinite wing. Infinite wing. Why it is called infinite wing? Because you know very well, if you take the cross section of the wing here, this is the airfoil now, and if you see the span length here, so span is what? Infinite. This is span, if you check, it's infinite, so for that reason airfoil is called as infinite wing. Infinite wing, and it is considered as 2D wing. I hope it is clear to all. So the point is, if you are going to calculate the aerodynamic center, so the aerodynamic center will be measuring from the leading edge. Suppose, see here we have a leading edge, so maybe this is the aerodynamic center, so this length, length will be measured like this. So aerodynamic center. Just say here we have a aerodynamic center AC. Okay, this portion. Now, so we have to calculate that value. Huh? How we'll get it? Check. We have a 2-3 steps. I will show you just for your understanding. I'm not going the thoroughly. I'm not going for the derivation because not required at all. But at least stepwise, I will explain you. So that formula you should have because they can ask numerical based on the aerodynamic center location and all. Okay. So now I will take one airfoil section. Okay, this is the airfoil section. Check everybody. This is what airfoil section. See, this is what airfoil section. Now we are going to check the chord length. Chord length, right? Now, basically, if you find the moment which is you are taking along x, so you can say this length what we have here. This length is nothing but x. Okay, this length is nothing but x, and somewhere at distance x you are say writing the moment. Okay, so obviously that moment whatever you will have, that moment will be called as mx. You are writing a moment from leading edge. Think about it. From leading edge you are writing a moment which is at distance x, so that moment will be mx. And at leading edge that moment will also be there, which is called mle. Mle is nothing but the moment at leading edge. Mx is nothing but the moment at point, at any point. I can say this point is nothing but o, at point o, which is from the leading edge, which is at x distance. That is the analysis I'm going to do here. So that why I'm writing in terms of x, because once I will change the x, you will get every time you will able to calculate at any distance x, you can calculate the moment. Okay, so now you can say that obviously if this is the one point, and at that point you also can say that force is nothing but which is just perpendicular to the chord line. That force is nothing but normal force here. See, normal force here, and this is nothing but horizontal force. Okay, right. So I have shown you here what is the MLE, single line I will write here. This is called a moment about leading edge. Moment about leading edge. Correct. Now, if you check the moment about leading edge, so I will write the taking moment. Moment about all the moment I will write about leading edge. Okay. So obviously horizontal force will not give any moment about leading edge because the action line will be same. But normal force will give the moment about leading edge. And that distance, the normal force distance is nothing but x. So what will be the formulation? You can say the moment about leading edge that already you have considered MLE. So what will be the MLE? MLE is nothing but mx is the clockwise moment, mx clockwise moment, and this normal force will give the anti-clockwise moment about leading edge. So it is nothing but n into perpendicular distance x, right? Now, so this moment actually, okay, in this way you have to calculate the moment about leading is, already you have taken moment about leading is mle, so that mle is equal to the moment, another moment which is mx. It is already in clockwise, so clockwise moment mx. But if you see the normal force, it is in upwards. So if you take the moment about leading is, so normal force into perpendicular distance x, which is in anti-clockwise, so put minus. This is the moment. Now what will be the moment coefficient? So if you write, because that also important, moment coefficient, check it, moment coefficient. So the moment coefficient, it is denoted by cm. Okay, you please concentrate, cm. So what is the cm? What is the cm? That is the moment coefficient. So always, I mean, any coefficients, if you talk about the lift coefficient or drag coefficient, so see the lift formula is what? 1 by 2 rho v square s, okay, into cl. If I ask you what is the cl, so this l is nothing but 1 by 2 rho v square into s. If you check this, L divided by rho v, half rho v square, it is nothing but dynamic pressure. If you see this half rho v square, it is nothing but pressure P, which is the dynamic pressure, into S, area. So lift divided by pressure into area is nothing but force. So if you talk about the half rho v square, so this half rho v square, it is nothing but the equivalent to the force. So lift is the force, half rho v square S is the force. So force divided by force, it becomes dimensionless. Then it comes CL. Check it now. So this CL is what? The dimensionless quantity. Dimensionless quantity. So if I say CL, then it is the lift divided by the force. That equivalent force, I must say. And if I say CD, so CD is, because this is the CL lift coefficient, so this force should be lift force, and this denominator force will be the equivalent force. Similarly, if it is CD, then drag force divided by the equivalent force. And what is the equivalent force? That equivalent force is nothing but half rho v square S, because half rho v square is the dynamic pressure into S. S is the area, pressure into area is force. So force is nothing but the equivalent force here. So similarly, if I say moment coefficient, so it should be the moment, and there will be the equivalent moment. I hope you all understood. Equivalent moment. Equivalent moment should be there. Just like, see this force. So CL lift coefficient. So it is the force divided by equivalent force. CD is the force divided by equivalent force. If I say CM moment coefficient, so it should be moment divided by equivalent moment. Now the point is, what will be this equivalent moment? If you see here, the equivalent force was half rho v square S, correct? Now if I say the equivalent moment, so you can say the equivalent moment is nothing but same, the force F. This is the equivalent force. There should be perpendicular distance, okay, and that perpendicular distance is nothing but the one more dimension, then only force into dimension, another dimension, maybe length, width, height, anything, but one dimension should be there, then only force into one dimension give the moment. So for that, C is the chord length of the airfoil, and always you will be writing the moment M from leading edge to trailing edge only, okay, on the chord only. So if you are taking C as a reference in equivalent moment, if you are taking C as a reference, so that C you can take sometimes C by 2, it means 50%, C by 4 means 25%, 3C by 4. Okay, so the point is, if C from leading edge to trailing is what fixed only, but if you take the quarter part of it or half part of it, so at least easily you can define, if you are saying C by 2, it means you are talking about the moment at 50% of the chord. So now equivalent moment will be force into chord. Hope you understood why C we are taking another dimension for the equivalent moment, because C is the one length which is nothing but fixed from leading edge to trailing edge, and all the moment, even though force you are calculating on the chord, only. So the partial part of the moment, partial part of the force, easily you can define on the chord. For that reason, you are writing C as a F into C as a equivalent moment. So now whole the formula I will write M divided by F is nothing but half rho V square S into C. So this is nothing but equivalent moment, ME, equivalent moment, just like this is FE, equivalent force. So this is the equal. So what is the pitching moment coefficient? Cm is equal to M divided by half rho V square S into C. Now I want the previous equation, what we have here, check it. The previous equation we have MLE is equal to mx minus nx. So what you will do? What you will write here? You will write MLE is equal to clockwise moment at distance x minus perpendicular force n into x. If I want to write, this is the moment, okay, this is what moment. Now I just want to write the moment coefficient. So what I will do, I will say MLE divided by the equivalent moment, it is nothing but half rho v square s into c. This is the equivalent moment. Similarly here also mx 1 by 2 s into c. So this is now coefficient. Obviously moment coefficient. Check, it will be converted now. It will be now CMLE. Check it. Is equal to CMX minus C. Everybody concentrate. X by C I can take outside. X by C I can take n half rho v square s. Again you see this part. N is the normal force and half rho v square is nothing but Fe, that is the equivalent force. So again this expression, one more line I will write, Cmx minus x by c into n. This will be the force divided by the equivalent force. Now force coefficient, just like a Cl Cd, we have a Cn here. So Cn is the normal force coefficient, just like a lip coefficient. Cl Cd is the drag coefficient. So Cn will be the normal force coefficient. So this is very important. Okay, this is very important. You just make a note of it. This is the coefficient of the moment or moment coefficient you are calculating. Okay, check it now. So Cn is nothing but normal force coefficient. Then this is very important analysis going on. Direct result also we can write, but I would say you just write few steps. So in problem, if they will ask, because I am writing the moment coefficient at leading edge. Okay, moment coefficient about leading edge, better to say. They can ask moment coefficient at any point. So if you are knowing the method, so easily you can calculate. Okay, so if I say this CMLE is equal to CMX minus x by c into Cn. So we just defined all those. So what is this? Check CMLE. You can say CMLE is nothing but moment coefficient at leading edge. Next, this is what CMX. Moment coefficient at 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 distance at point O, distance x from leading edge. Okay, and here see this part. Length from leading edge with respect to chord length. Okay, and Cn already you have defined. Cn is nothing but, check it. What is the Cn? Cn is nothing but normal force coefficient. Okay, this one you need to remember, dear. It is very helpful. It will be used sometimes. Okay. All right. Now, based on this, as you already have seen about the aerodynamic center, it is going for the. We are trying to get the final result for the aerodynamic center. So in that,
Sorry, it was backslide.
right. Do it fast here. Today we'll derive both aerodynamic center formula and center operation. Huh?
सर वो वहाँ पे एस होगा क्या हाफ रो वी स्क्वायर एस सी होगा या सिर्फ सी होगा
Sorry. Please
सर वहाँ
speak
पे
loudly. Yes. हाँ.
हेलो सर सी एम एल ई जब लिख रहे हैं तो एम बाई हाफ रो वी स्क्वायर सी होगा या सिर्फ एस सी भी होगा
एक second. Just let me check. MLE divided by half rho v square S. So this half rho v square S is nothing but force. So force into C will give the moment. So moment by moment. Then you will get the coefficient which is called moment coefficient. What is the problem here?
सब हाफ रो वी स्क्वायर सी नहीं हो
No, see the moment coefficient of moment or moment coefficient is always moment divided by equivalent moment. Little coefficient force. So pressure into area becomes force. So force into one distance which is called chord length F into C. So it becomes half rho SC. So this is now the equivalent moment. Half rho v square SC will be the equivalent moment. If you want to write the moment coefficient now, this is the moment equation. Now if you want to write moment coefficient, so you have to divide with the equivalent moment. What is the equivalent moment? Half rho v square SC. Half rho v square SC. Half rho v square SC. MLE divided by half rho v square SC becomes CMLE. MX, this is also moment, so half rho v square SC divided by CMX. This X and this C you can take outside. It becomes N divided by half rho v square. What is the N? I have shown you in the diagram itself. N is nothing but the normal force. So if it is the force, then if you are writing the coefficient, so it should be force divided by equivalent force. Just now I have shown you Fe, which is nothing but half rho v square S. That is the equivalent force. So here you will have, if you have taken C outside, so only inside you will have half rho v square S, which is equivalent force. So N divided by equivalent force becomes Cn. Now what is the question? Now tell me. Is that clear or still you have any question? You please ask.
नो सर
Huh? Done?
clear yes sir
Very good. Okay, so moving for the aerodynamic center. Aerodynamic center, which is nothing but XAC. That is the aerodynamic center XAC. Okay. Now if you see one points you will write here as well. Okay. The point about which the change in resultant moment with respect to the angle of attack is 0. So this is the theory, but how mathematically you will write, because Sometimes they will be asking the mathematical part also. So mathematical part you can write the point about which the change in resultant moment with respect to angle of attack is 0. So obviously you can write dm by d alpha is equal to 0, as also moment I have also written in in terms of coefficient. So dou cm by dou alpha also you can write. So this is the meaning of it. So anything you need to written, and a question will be asked to you. Now coming to the next point 2. Okay, the same thing. I mean, because you see that for the airfoil you have seen already. It's nothing but CL versus alpha curve. So this is the CL versus alpha curve. It's a linear. It's a linear, correct? It's a linear. So, and also you know for the thin airfoil, you know the formula CL is equal to 2 pi alpha, correct? So dou CL by dou alpha, it's nothing but 2 pi, which is constant. For this is for airfoil, you know that. So for that reason, in this, you can, I mean, this concept you can further use for the this formulation. So also you can write this dou m by dou cl also you can write is equal to 0, or dou cm by dou cl. Remember it there. Okay, this is for what? This is for the aerodynamic center, and each and every points are very important. You please make a note of it. What is the I mean, how in statement how you can write it? So again, it's very easy for you. You can write it is a point. It is a point about which the change in resultant moment or moment coefficient with respect to lift coefficient is 0. That's the mean of it. So anything they can ask, I am writing seriously. Why? Because there should not be any confusion. Sir has told only angle of attack. It should not be with lift coefficient. No, that will also be there. Use this concept. I hope you all are aware with the thin airfoil. Correct. Anyway, this is the one. One more point I have to give for the aerodynamic center, which is nothing but third one. Okay. So the third point is nothing but, check it. It is a point. It is continuously. I'm continuing for the aerodynamic center. Okay, so it is the point. It is the point about which the resultant moment or moment coefficient is constant, right? What mathematical formulation you can write? Mathematical model for this is nothing but m. M should be a constant at aerodynamic center, and in terms of cm, because just now you have seen it is derived, so cm is nothing but constant. Okay, so these all 3 points are very important. The same thing it is only, but the changes, the how the statement or the formulation can be changed. I all have written all 3 points. Okay, 1 2 3. So you need to remember here. Okay, and this one is nothing but third. What they have asked in different exam, what they can ask, all I have summarized here, all I have written. Now it's your duty to remember everything. Okay, correct. Now again we'll be moving for the calculation of aerodynamic center. How you will do that? I will write here the heading. I will give calculation. Calculation, or you can say formulation. Okay, formulation of aerodynamic center location. How you will get it? This is again very important. So see what the formula you have right now, what I have given to you. I have given, you see the standard formula previously, it was CMLE, moment about leading edge, is equal to CM check X. X was the distance from leading edge. Okay, minus it was X by C into Cn. This was the formula, dear. Check. Now, if I say, if because X is the arbitrary means if you can say you can take at any distance from leading edge to a trailing edge, in between anywhere you can take this X. See, so this X is the one variable. This X is what shifting actually. This can be anything. At leading edge, X is equal to say 0. At trailing edge, X is equal to say C. In between, that value can be anything. So your aerodynamic center also will be lying on the chord itself, but it should be in between leading edge to trailing edge. It can be anywhere, but it should be on chord and it should be in between leading edge to trailing edge, correct? So I can say my aerodynamic center is XAC, because XAC is number the location of aerodynamic center. So I am saying somewhere aerodynamic center is what located, and this that distance, you know, XAC already I have defined. XAC is the location of aerodynamic center. So I can say here for aerodynamic center, I can say that location of aerodynamic center here, location from leading edge, and that is nothing but from leading edge, X is equal to XAC. Instead of X, this X you can replace XAC. Instead of X, you can replace this XAC. CMLE, you are not going to change. Why? Because this moment is what about leading edge. So that moment about leading edge is not going to change, because aerodynamic center is the one location. So instead of X only you can change. Rest everything will be same only. Right? So what you will write here? What you will write? So you can say now X is equal to XAC. So the formulation will be changed. CMLE, moment about leading edge, is equal to CMX. So instead of X, it is nothing but CMAC, moment about aerodynamics. Right? Okay. Minus, instead of X, it becomes XAC divided by C. And it is nothing but CM. All right. So the point is C, because if you check this one, here I will write this equation. See, this is equation number 1, you can say, and this equation is, you can say, equation number 2. What is the common in this two? What is the common? CMLE is the common. I told you CMLE is not going to change because it is the moment about leading is correct. So what you can say, that simple equation you can write from equation 1 and 2. From equation 1 and 2, right? You just see this. Just right. So here, see the equation 1 and 2. Right? So equation 1, equation 1 and 2. This is equation 2, and here we have equation 1. See, this is what equation is the constant. So we get EMX minus S by C, it was Cn, correct, is equal to this, which is nothing but Cm AC minus XAC by C to Cn, right? Concentrate on the CMAC. What will be the CMAC then? You can say CMAC is nothing but CMX, and you XAC by C, you will put this side, so you will have XAC by C minus X by C, and it's nothing but in bracket, which is nothing but CM. Correct? So this is the first of all, this is the formula what you have here. Okay, this is the pitching moment coefficient about the aerodynamic center. The all value they can give to you, which is but the pitching moment coefficient about aerodynamic center, which is very important parameter. Okay, pitching moment coefficient about aerodynamics. This is very important parameter, right? Then moving to the next, we are very much interested about the location of the aerodynamic center. So now we have CMAC, we check formula CMAC is equal to CMX. CMX XAC minus X by C. CM. Right? So now what you do? Simple. You can use the aerodynamics center definition, and based on that, you can say that as per AC definition, at AC, the moment coefficient must be 0. So at AC, you can say moment coefficient must be 0. CMAC by alpha. I mean, the change of moment coefficient about aerodynamic center must be 0. That is the basic definition of the aerodynamic center, right? Because you had seen that moment coefficient must be constant at aerodynamic center. So if you take the depreciation is basically, it will show the change of the function with respect to variable. So dCm AC by or dCm AC by dou alpha must be 0. That is the aerodynamic. Or I have told you, you can write both. It's your choice what you want to pick. Both are the same. Okay. So if you do that, this equation, just say this is equation number 3. What you will get from C, you will have now dou CMX you can take Cn this side, so dou Cn by dou alpha in root. Okay, as per definition, this part should be 0. This part should be 0, right? So what you will get, you can take one side x, because x AC by C will be the basically, so you can use this equation, x AC by C will be x AC by C, x by C go this side, will come this side, so it will be x by C. Okay, x by C minus, here we have a dou Cm, this one dou Cmx by dou alpha divided by this one dou Cn by dou alpha. Take it. Everybody should be agree with this. I have skipped 2-3 steps, but not required. Directly you can write here, right? So what is this x AC by C? That is the important. This x AC by C is the location of the aerodynamic center. It's a location. Check the diagram here. See, this is the mx. Somewhere there will be aerodynamic center. Okay, somewhere there will be aerodynamic center. So if you will see x by c or x ac by c. So x is the distance from the length and c is the fraction. C is the basically chord length, and if you are writing x by c, so it's a fraction of chord. X by c means what? The length with the fraction of chord or per unit chord. X by c, you can see the length from leading edge to a point with respect to chord. That is the mean of x by c. So if you are having this all the time, so ultimately what you got, x ac is equal to x ac by c is equal to x by c minus something. So you can say if here is what x, this total length is x, so your aerodynamic center, it's just without calculating anything, just simply saying this is now aerodynamic center. Okay, and for this aerodynamic center, obviously the moment will cm ac, correct, and this location, this I'm talking about this x. I hope you all are agree with this, correct? So finally what is aero, which is nothing but location of aerodynamic center, then aerodynamic center from leading edge with respect to c. So what will be the value? What will be the value? It will be x ac by c is equal to x by c. Check it, minus dou cmx by dou alpha divided by dou cn by, please put in box and should be remembered. Okay, it should be remembered. This is very important. It's a location of aerodynamic center or position of aerodynamic center, correct? Oh, what is the takeaway point? See, note for your gate. Check note number 1. What is note number 1? You just see aerodynamic center x by c, x ac by c. That is the position of aerodynamic center x ac by c. Does not, check it, does not depend on aerodynamic coefficient. If I say aerodynamic coefficient is all three, what are all three? CL, CD and CM, moment coefficient. You see it, x ac by c by c in the form of x ac by c does not depend on aerodynamic coefficient. It is not depending on aerodynamic coefficient. C is subjective, AC is there or C is there, CD is there. No, it's not there. This is very important. Sometimes in statement they will ask question you remember. Okay, so you can say x ac by c, and what it is depending? It is depending on dou cmx by dou alpha. It is depending on dou cn by dou alpha. So I can write, so x ac by c depends on it is derivative of aerodynamic coefficient. What derivative of aerodynamic coefficient called? Derivative of aerodynamic coefficient, what it is called? You can say this is called as the change. So the change of the moment coefficient, the change of the aerodynamic coefficient is nothing but or derivative or change. Both are the same thing. I told you starting labeling what is a change. So you can say the aerodynamics center will not depend or does not depend on the aerodynamics coefficient, but XAC by C, which is the aerodynamic center, depend on derivative, or I will write both. Okay, derivative or sorry, or change of of aerodynamic coefficient, derivative or change of aerodynamic coefficient with respect to angle of attack. You please remember this. Okay, so what is the mean of it? The change of aerodynamics coefficient with respect to angle of attack means this: dou cm x by dou alpha or dou cn aerodynamic force dou. So statement will be given to you, and it is very almost very close to each other. If you see the both statement are very close, okay, but you see just opposite. One is depending, one is not depending. That you keep in your mind. See the formula, and you can frame the theory part of also, and they can ask question in gate. So you please prepare for this. Okay, this is done. So all the information what was the required for your gate exam that I have discussed here. Now we will be talking center of pressure. Already I have discussed center of pressure, but mathematical model I have to give to you. So what is the mathematical model for the center of pressure? Check everybody. Center of pressure. See, center of pressure. See all of you. Center of pressure, correct? What is the center of pressure? It is, first of all, it is denoted by XCP or only XP also sufficient, XCP or XP only. So the basic point you know that a point about which resultant moment is zero. Okay, what is the second point? A point about which the resultant coefficient is zero. Okay, both are the same thing. So the point is, you can say that m is zero or cm is zero. Okay, this is the all about aerodynamic center. Now we have to use the same governing equation with respect to about leading edge moment we had written. So from, see the previous one, from equation 1, check what was the equation 1. If you remember, the equation 1 was moment about the leading edge CML is equal to from equation 1 previous CML. I had shown you that it was CMX minus x by c into CN. This was the equation. That was the equation 1, if you remember. Now the same thing you have to read for the center, just like aerodynamic center. Now this x length, you can say this x is nothing but xcp, that is nothing but center of pressure, correct? Then obviously for cmx, you will have this cmx will be replaced by cm x instead of x only. You can write xcp, cmxcp, or simple you can write cm CP, means pitching moment coefficient about center of pressure, right? And you see, so you just replace this, so this equation you can say now This is the equation. Okay, anyway, just for here only, I will say this is equation A, and just once you keep this value, so this equation will be what? Check CMLE. We just keep the value of x here, so it will be CM CP minus x is x will be x CP by, and this is not CN. So this is say equation B. Again from equation A and B, if you see, so you equate CMLE will be same only. See, this CMLE will be same only. So equate this. So what you will get finally? Check it. You will get CM CP minus XCP by C. Cn is equal to Cm x minus x by C into Cn. This you will get, right? Ultimately, what the final expression you will have, check. You have seen the Cm CP must be 0. Just now, as per definition only, the moment about dynamic center of pressure, so this Cm CP must be 0. M at center of pressure must be 0. That's the mean of it, right? You just put here, now you will get. So ultimately, if you check, you are much interested about XCP by CP because this is the center of pressure, correct? So now onward, you just perform the same, just like for aerodynamics. So if you solve this equation direct, I will write. You will get XCP by C is equal to x by C. This equation you will get it x by C, and obviously C is there, so C will be common, and then finally what you will get x by C minus CMX by C. I have only Cn I had taken common because Cn is here and Cn is here. So this you just perform the steps. You will get. Now this is the final expression for the center, which is the location of the center of pressure. Okay, location. This is what location of pressure. Okay, now you see it. What is this Cn? This is the say force coefficient. Don't say only force coefficient. I should correct this. And aerodynamic force coefficient or aerodynamic coefficient. I must say I should correct this aerodynamic coefficient. I should write aerodynamics. Check it. It can be a CL. It can be a CD. It can be CM as well. Now you see the variation. This is again very important. Okay, you got it. You got that. But very important that takeaway point for this. What is takeaway point? Check it, everybody. If you see, to write the XCP value here, check XCP by C is equal to x by C. Okay, minus is that CMX. Now see the important point here. Point 1. What is that? C. That XCP by C. Check it. This is the location of the center of pressure. So this XCP by CP, XCP by C depends on magnitude. See, Cn is what? Aerodynamic coefficient. So directly you can write, because once Cn will be anything, Cn can be anything. It may be Cm, Cl, Cd. So XCP depends on magnitude of aerodynamic coefficient. Aerodynamic coefficient, right? Right. Now, but But what is the second point for this? You can say XCP by C does not depend on derivatives of aerodynamic coefficient. This is very important. Okay, analysis you need to remember with respect to means in case of aerodynamic center and center of pressure, it is just opposite. So you just remember it. Okay, always center of pressure is what depending only on the aerodynamic coefficient. Huh? But aerodynamic center does not depend on aerodynamic coefficient. It is depending on the change of aerodynamic coefficient with respect to angle of attack. Just opposite aerodynamic center and center of pressure, right? Always remember this. Anyway, also see, sometimes it is required to need to develop the relation between the aerodynamic center and center of pressure. Sometimes it is required. Okay, so that formula also you should write. That formula also you should write here. I will give this. So just write down the relationship between the center of pressure and aerodynamic center. Okay, center of pressure and aerodynamic center. Right. Between AC and C is, this is very important. You should know this. So you can say that actually you see it that moment about aerodynamic center. I mean, you can derive also, but now already you have derivation, so you can manipulate data and directly you can find the relation. We should not continue this derivation every time. So just already have, you just take the data from there, aerodynamic center and center of pressure location, and you just write few steps, then automatic that derivation you will get. Uh, so this is but XCP. XCP by XCP small XCP by C minus XAC by C is equal to CMAC, means moment about aerodynamic center divided by CL. Okay, means, or you can say XCP by C is equal to XAC by C, okay, plus CMAC by CL. CAC by CL. Okay, generally moment about aerodynamic center is what positive. So if you check the location of the what it is called center of pressure and aerodynamic center for a wing from the leading edge. Okay. Start from leading edge, all the measurement. Now you check it. So it is along the chord length only it will be there. So I have taken a chord. You can say this is the chord. Okay. You can say this is the one and this is the another one. Check which first one. You see it and tell me. So this is now it is called, this length is nothing but X. To say this length is nothing but X AC, correct? And this up to here. So this is what aerodynamic center, and here this length should be XCP, because XCP is nothing but aerodynamic center plus some distance. So this is the location of pressure. Okay. I hope you all heard this. Always remember, aerodynamic center is almost constant. It is fixed. It is changing with the angle of attack. It is generally C by 4 distance, but CP is always changing. And also AC and CP can lie on the point because the aerodynamic center is fixed, but CP is not changing with the spin of attack. I have given the note, so who understood? Once alpha is not changing, CP will be changing. There will be some specific value of angle of attack where AC and CP can coincide. So yes, a question can be asked to you. It can coincide. Yes, it can coincide. There is no doubt about it. Totally depends on the angle of attack. Because AC aerodynamic center is what not going to change with angle of attack. It is almost fixed, and it is almost 25% of chord C by 4 distance. But CP center of pressure is always changing with angle of attack. So there will be a certain angle of attack where AC and CP can coincide. You need to remember, okay? At specific angle of attack, AC and CP can coincide. I have given, okay? So that one note should be there. Always you should remind this, can coincide. Okay. All right. So from my side, this the whole analysis which is related to the aerodynamic center and center of pressure is what done. This formula, remember here, okay, sometimes question will be asked to you. So location of the center of pressure, aerodynamic center will be given to you, moment about the aerodynamic center will be given to you, lift coefficient will be, everything will be known, only the formula. If you don't know, then you will not able to calculate. And this derivation is very easy. Whatever I have done previously, you just connect all the equation, and if you do that, then you will get it. Okay, it's very easy only. Anyway, so from my side, AC and CP is what done, because it is very very important once we'll talk about the longitudinal stability. It was just a basic or background or foundation for the longitudinal stability, because once we'll start longitudinal stability we'll talk about the AC, we'll talk about the CP, so you should at least aware with that. Okay, anyway, now moving to next fresh topic, which is called longitudinal static stability. Okay, so I'm just going to start this. First I'll say longitudinal stability. In longitudinal we have a two part. One is called longitudinal static stability. Another is so our first is nothing but first we are going to discuss this static stability. Okay, so if you talk about the longitudinal static stability, in the longitudinal static stability we always have a pitch up, pitch down. This one you need to write: pitch up, pitch down. Okay, obviously it is also called nose up, nose down. Okay, and what type of moment we are going to discuss here? We are going to discuss, say, pitching moment. We have to calculate pitching moment about CG. Okay, and this pitching moment you are going to calculate about which axis? Say about which axis we are going to calculate this pitching moment. Somebody can tell. It is about, I should write about, say, lateral tell me the major parts of the longitudinal static stability. How many components, major components are going to contribute longitudinal static stability? You have to make it stable, correct? So the components participation we have to check. We have to check the participation of the components. Say we have to check the participation of the component, how it is contributing positively or negatively, what is the impact of it. For that, we have a three major component. We have a three major component. So many components in the aircraft we have, but if you talk about the three major components, so these three major components are nothing but main wing. Okay. Next is the fuselage. Next is the major component tail wing. So one by one, all three component contribution we have to see, we have to check, we have to analyze, and remember this. Every year question they are asking from the longitudinal static stability, and yes, among all three, all components are important, but among all three, one will be asked to you in your exam. Okay. So anyway, we'll see. First, we'll give heading the main wing contribution. Okay. We'll write the main wing contribution. Main wing contribution. Main wing contribution in say LSS, longitudinal static stability. Okay. Longitudinal static stability. Let me somewhere write this LSS, longitudinal static stability, correct? So the main wing. Okay. Now, so you have to, as I have shown you already, that sign convention, when it will be positive, when it will be negative, that already I have told you. So I'll show you, because we are talking about the main wing first. So check it. Just say this is the reference, okay, line basically for the aircraft. Now, if you talk here, the airplane, sit. If you see the airplane is nothing but this is the orientation of the airplane. Okay. Like this. See. So here, if you check the from the reference line, okay, see this angle, you just say alpha 1. This is alpha 2. Okay. So if you see here, the alpha 2 is greater than alpha 1, which means there is the nose up. Okay. So if the nose up condition is there, so you want to stabilize the aircraft, then what you will have, what type of moment you should generate? It should be the anti-clockwise, because it is nose up means it is going up. So to make it stable, that aircraft should be applied the counter moment, which is nothing but ACLK, anti-clockwise moment. Anti-clockwise moment should be there. So now the pitching moment about the center of gravity, that moment, whatever it is generating, that moment in anti-clockwise direction, it should be in downward direction, and that should be the MCG. This moment will be basically this moment which is anti-clockwise moment, and it will try to get back to its initial condition or initial position of this aircraft. So this MCG, okay, this MCG is basically called, I should write here, MCG is called, which is the anti-clockwise movement. That's the reason it is also called a restoring moment. What it is called? A restoring moment. Okay, this is called restoring moment, and this will give the positive impact. Okay, restoring moment, which is nothing but MCG or CMCG. this mcg, because it's a anti-clockwise, it's a anti-clockwise moment, anti-clockwise moment, hence this sign convention must be negative. Okay, if it is going up, so this will be the clockwise moment. So clockwise moment, clk, clockwise moment must be positive, anti-clockwise moment must be negative. So you can say mcg, or in terms of coefficient you can say cmcg. This should be negative, this should be negative for the stability. It is required for the stability, for the stability it is required. Okay, for the stability it is required, to make it negative moment. So cmcg pitching moment, I should write what is the pitching cmcg, that also need to write here. So every time I will be writing only cmcg here, just I want to write. So this is nothing but the pitching moment. I can say this is the cg. Okay, so this is what pitching moment, pitching moment coefficient, no? Pitching moment coefficient about cg, about cg. So pitch down or nose down moment considered to be a negative moment, and pitch down or anti-clockwise moment will be considered negative. That already I have shown you in the graph. So this is the one thing. Second thing, if you are writing the moment slope in terms of the slope, because this change here I have shown you this moment change, cmcg, which is basically with respect to angle of attack. What is the alpha? Alpha is nothing but angle of attack. So how to relate this cmcg with the angle of attack, that I have to show you. So you just remember this graph. Okay, this graph is very important. This is nothing but, you can say, moment mcg, or you can say it's a cmcg, it's your choice, the same thing only. And this is nothing but, say it is nothing but alpha. As I have told you, alpha also can be taken as cl, that cl you can take in terms of the variation, because cl is equal to 2 pi alpha. Last class I had shown you. So cl is always directly proportional to alpha. Any parameter which is changing with respect to cl, so obviously it will also be changing with respect to alpha. That's the meaning here. Okay, now if you see the stability criteria for the longitudinal the stability criteria, so it should be, the graph should be like this only. This should be a straight graph. That slope will be somewhat like this. Okay, so this slope, whatever the slope you are finding here, whatever the slope it is making, this slope, check it, this slope is the negative slope. Why? Because you have seen for the stability cmcg should be negative, so for that reason you are getting the negative slope here. So obviously if you take the part of this, so y-axis is nothing but a small component, which is, if you are taking dou cmcg, dou cmcg, and this is nothing but you are taking x-axis, which is alpha, it will be dou cm by dou alpha. So if you see the slope, this should be negative. So what is the fact here you are getting? You can say dou cm cg by dou alpha. See, what is the slope? Slope is what? Negative. So you can say less than 0. Also you can write, or that meaning is same only, dou cm cg by dou cl. What will be the slope? This slope is what? Negative, 0. Or this can also be written dou m by dou alpha less than 0, or dou mcg, this is the dou mcg by dou cl. That should be. This was not one time, not two time, multiple time in your gate exam they had asked. This is the one criteria. It is the stability criteria. What is that? Stability criteria. Not one time, multiple time they had asked here. It's a stability criteria. Generally what they are writing, cmcg alpha they are writing. So that's the meaning is the dou cmcg by dou alpha. What should be that value? They will ask cmcg alpha, they will ask greater than 0, less than 0. So it always less than 0. That is the negative, because then only you will get the negative slope. And that negative slope indicates that dou cmcg by dou alpha is less than 0. And here it also indicates that cmcg must be less than 0, which means it's a anti-clockwise. That means nose down. Nose down is the anti-clockwise movement, which is the restoring movement. Correct? Because disturbance will hit and it comes and hit to the aircraft, so there will be nose up. So there will be a clockwise movement, which is not intentionally. It is It is not intentionally, it is because of the disturbance. The increment or the clockwise movement generating in the aircraft, it is not intentionally, it is because of the disturbance, because of the gust. So if it is not intentionally, so definitely pilot will try to get back to its original position. So what pilot will try to do? The pilot will be using the elevator to make it nose down. So it will be generating a anti-clockwise movement or called restoring movement. So because it is anti-clockwise movement, it should be negative. So if you talk about the criteria for the stability, so anti-clockwise moment required, which to make it nose down the aircraft. So the criteria, first criteria you got that CMCG must be less than 0, or that change of the CMCG with respect to alpha must be less than 0. This is very, very important here. They have asked in GATE exam, okay, not one time, multiple time, okay, they had asked. So this is the one criteria I have given to you. You please remember, okay. In very common word, they are using CMCG alpha, they are saying. So they will ask it is positive greater than 0 or less than 0. So you have to say less than 0, because CMCG alpha means dou CMCG by dou alpha. This one. That's the meaning of it. Okay. All right. Now, so here I'm going to talk the main wing again here, because we have started working for the main wing contribution here. So first of all, you got the criteria, which is very, very important. Okay. The second criteria I will tell you, that is nothing but CM naught. So here only I can write. Okay. The second criteria also I should write here. I'll show you. Check somewhere here where this graph is what cutting. See, please concentrate now. This graph, where this graph is what cutting at this point. Check it. Check everybody. When you will get negative slope, obviously when the graph is what cutting here. I mean, this I'll show, I'll take another diagram, so it should be very clear. Check one criteria you got, which is very clear and very fixed. It is not going to change. That if it is the CMCG and if it is the alpha or CL, okay, anything you can take. So the aircraft will be longitudinally stable when there is the negative slope that you got. This is the negative slope. If I say this is my slope, check it. If I say this is the slope now, so this slope is what? This is the positive slope. And this is what? Negative slope. Yes or no? This is the negative slope. I should write here. Negative slope. This is the positive slope. Positive slope means what? It is going to nose up. Positive slope means what? Nose up. Now you say nose up will be boosting the and it is the nose up condition will be leading to unstabilize the aircraft. But at the same time, if there is a negative slope, that means nose down. So nose down will leads to the aircraft to reach its initial position or initial condition, which is it is leading to stabilized condition. Okay, so this negative slope and positive slope, one thing is very clear. So which one is acceptable? I mean, if I say which one is acceptable, so definitely this is acceptable. This is acceptable, nose down, but this is not acceptable. This is not acceptable. Because not acceptable. Why? Because it is longitudinally unstable. It is leads to unstable condition. Leads to unstable. And this leads to, say, this leads to stabilize the aircraft. Correct? You please check it here. This is very, very small thing, but very, very important actually. So ultimately one graph you got, I should say here, this graph, you please make a note of it, everybody. This is very important. Now, based on this graph, I'll show you one thing. Okay. So the final, you can say you are now very much confirmed that to make it longitudinally stable aircraft, this slope should be negative with respect to alpha or with respect to CL, anything, no? Anything. So this slope should be negative. Please check it. This slope should be negative. So this slope will be somewhat like this, right? Now my concern is, what is this condition where the graph is what cutting on y-axis, or y-axis is nothing but CMCG. Can you say the CMCG means if it is cutting here, so this what is the value of CL or alpha here? The value of CL is nothing but say 0. The value of alpha is nothing but say 0 here. Because CL is 0, because you know CL is nothing but 2 pi alpha. So if the CL is 0, so alpha is 0, or alpha is 0, so CL is 0 for symmetry, careful. Correct. So now you can define basically CMCZ. Please concentrate now. CMCZ will be called as CM naught. CMCZ will be called as CM naught when the CL is equal to 0, or when the alpha is equal to. So the value of CMCZ where lift is 0, the value of CMCZ where the lift coefficient is 0, that value of CMCZ called as CM naught. So easily I can say this is nothing but CM naught. Now this is called second criteria. This is called second criteria. Very pinpointed thing I am trying to discuss here technically with the diagram. So you please listen carefully. Okay. This is the second criteria for the LSS, longitudinal static stability. This is the second criteria. What is the criteria you got? Still tell me. CM naught. They will ask to you. CM naught. It should be positive or negative. It should always be positive. Because first criteria you got, that should be a negative slope. If it is negative slope, so CM naught should be positive. I mean, here also CM naught you will get. Check. I can say this side also CM naught you will get. See, this is also CM naught. Okay, this graph. This is also this is also CM naught, because here also CL is 0. Here also alpha is 0. But see, this CM naught is acceptable for the stability. No, this CM naught you will get. This CM naught is, first of all, this CM naught is what? Negative. It is below the origin. So if it is not acceptable, why it is not acceptable? You can see right side, not acceptable because it leads to unstable. And the CM naught negative you will get, not acceptable. You will get negative when there is the negative slope. But first criteria is you don't want negative slope, because if negative slope is there, then there will be a nose up condition, and nose up leads to unstabilize the aircraft. Nose down is only leading towards the stabilizing the aircraft. So if it is nose down, so there should be a restoring moment, there should be anti-clockwise, and that anti-clockwise moment always considered a negative moment. So that slope must be negative with respect to moment and alpha. That curve should graph, or the slope should be negative. So for the negative slope, this CM naught should be positive. This is not one time, not two time. If you see the previous year gate question, multiple time they had asked this criteria, okay, with different format, with different combinations. So ultimately the LSS criteria, if you see the separate separate, you had seen the criteria, but now the combination is, see the combination. What is the combination? DMs CZ by dou alpha must be less than 0. Also you can say dou CM CZ by dou CL must be less than 0. And the second is nothing but CM naught must be positive. So I hope this is very clear, right? Because this is not a simple thing. Whatever I have taught you, this is the main conclusion for the longitudinal static stability. Now, continuously, next 4-5 lecture, you will be working for this. Everywhere you will be finding this CM not positive, and dou CM CG by dou alpha, or dou CM CG by dou CL should be negative. If it is just opposite, means that component, it may be fuselage, it may be main wing, it may be tail. Every component you have to check, the major component you have to check. If they all the components component basically satisfying this criteria, LSS criteria, and if it is satisfying this, then only it will be contributing positively. If any component is not satisfying this criteria, then it will not be contributing the positive. It will be contributing negative impact to the to the whole aircraft. I hope it is very clear. So that's the reason it was very important to discuss here first before starting the main wing or something. It was very important to discuss this. Now I will be moving towards the main wing contribution. Okay, so listen carefully and I'll continue this will next 30 minutes more. Huh? So check here onward. I can take the one aircraft because we are talking about the main wing contribution here. Main wing contribution. So you see the aircraft. Check, this is what aircraft here. Okay. You see this horizontal component, obviously. This is the horizontal stabilizer for the tail, and here this is the main wing basically. Okay, right. Now see, so for this aircraft, if you check basically the lift which is generating by the wing component, so here you can say that the drag is nothing but just opposite to the motion of the aircraft. So this is the drag, and the main which is the lift. The lift is what generated by the wing here. Okay, and obviously you will be talking the lift generation and all at aerodynamic center, but at the same time here the CG we have here. Somewhere here we can say this is what CG. We'll check CG and AC location later on. So W will be the force which is nothing but acting downward direction, which is nothing but weight of the aircraft. Okay, and this is what the tail. So this is the tail. So tail also you can consider the CG of the sorry, aerodynamic center of the tail also will be there. So this tail will also be producing the uh, lift force. So now especially you are going to talk the main wings. So I will take one main wing here. This is the basically, see here we have a fuselage. We'll also check the fuselage. It is contribution. Its contribution. This is what the main wing. Okay, main wing contribution. Major component I'm talking, and this is the tail wing. Okay, tail wing contribution. So first I have started main wing. So main wing, see the diagram for the main wing separately. I will show you the main wing contribution. I will take the main wing first, and for that main wing I will take the airfoil, obviously. Main wing contribution. Okay, main wing contribution. Check it. Main wing contribution. So see this main wing now. I will draw this diagram, and from here we'll start check. This is the main wing basically. Okay, right. This is the main wing. Check it. So here you can have that the chord line which is meeting trailing edge. This is what leading edge. This is the main wing only. So I will be showing the chord length C. This is called chord, chord line or chord length. Okay. So aerodynamics center I will be showing on the chord first here. So I will be taking somewhere. This is the one location for the aerodynamic center where I'm just showing the force. So, and because this is the main wing, so if you talk about the whole CG of the aircraft, so I'm considering that whole CG of the aircraft is what somewhere here. Check. This is the whole CG of the aircraft. This is the main wing I have taken here. So this is the whole CG of the aircraft. Whole CG of the aircraft. Okay. Right. Now you think about it, and right. Anyway, all right. So I can say because that all the forces I have to show here, I'm considering first that whatever the flow, that flow is direction is what, something like this. Something like this. This is the flow direction. So it will consider relative bend is here. To make it simple mathematics, I am taking relative bend with some angle. Otherwise, if I will take straight relative bend, so I have to keep my wing or airfoil with some inclination. So instead of keeping airfoil at some inclination, I am keeping relative bend some inclination. So meaning will be same only. So whatever the alpha is nothing but angle of attack, but it is for the wing. So alpha W, and the direction of the flow, which is nothing but v infinite, it is like this. So this always, you know, the angle of attack is always the angle between the relative wind and chord line. So this is what chord line, and this is the relative wind. So in between that angle is alpha W, correct? Now I'm considering that this part is nothing but here, what it is called, this is the aerodynamic center. So I should take aerodynamic center here. So from the leading edge I will take all the distance, and I will be measuring. This is the, check it. The whole distance is nothing but c, from here to here. Check it, from here to here. This is nothing but c. Okay, this distance I can take aerodynamic center. So generally I have taken XAC in my previous all the analysis aerodynamic center. I have taken XAC. Okay, so we can continue with the XAC, or also we can take the standard book. If you take the John D. Anderson, that you know, uh, book, they have denoted aerodynamic center by H uh, A HAC, you can say HAC aerodynamic center H, they have taken like that. So if you want to take that, otherwise if you say XAC, I will continue. For me, I do not have any problem. The point is, if you read the reference book, so there should not be any confusion. That is the main concern. Okay. Anyway, so for that reason, I'm also going to take the same notation, which is nothing but HAC. So HAC is nothing but the location of aerodynamic center from the leading edge in fraction of c, in fraction of c, c for the chord line, chord length, c for the chord length. So in fraction of c, I am just taking the aerodynamic center location from the leading edge. Okay, now next, what I have taken cg somewhere, I have considered, okay, this is the cg. So this cg location from the leading edge is nothing but, CG location is what denoted by H, and it should be in also fraction of chord, so it is nothing but HC. Okay, this is the notation, always remember. So, and if this is what the horizontal reference line, this is also, you can say, a reference, this is also a reference line. Your chord horizontally you have kept this airfoil, so this is the reference line also. So from the reference, the CG location vertically, this height is nothing but Z. In percentage of chord, it is C. Correct? Now you denote all the forces on the surface of the wing or on the surface of the airfoil. So again, you have to concentrate. Now check. You always define the lift force, which is always perpendicular to the free stream velocity. So your free stream velocity, you see, this is your free stream velocity. Check everybody. This is your free stream velocity. You have taken this relative velocity, something like this. So definitely that lift will be perpendicular to this. So if this is the velocity component here, So I can take, I will, if you say, I will show you this is the velocity component v infinity, which is nothing but relative velocity. I should say somewhere here. Check this relative velocity. So same I have parallelly I have taken. Now it is now very clear the lift will be perpendicular to this. So where is the lift? This is nothing but lift. For that, or just wanted to show the lift, for that reason v infinity I have taken here. Okay, otherwise no need to. So just perpendicular. So check it. It looks like perpendicular or not, but I hope you theoretically you understood that lift and free stream velocity should be perpendicular, no? So this is nothing but your lift force. You please correct it, no? Lift force L, right? This should be 90 degree. This should be 90 degree. Okay. And here, if you check the moment about the aerodynamic center, moment about aerodynamic center is nothing but MAC. Moment about aerodynamic center is nothing but MAC. Next, another things I also have to show. If this is the lift, so where is the drag? If it is the lift, so where is the drag? So drag will also just direction of the motion. If the velocity is what coming in this direction, so definitely drag will be here only. Check, this will be the drag. All right, this will be the drag. Now if you see, this is the alpha w, so this will also be a alpha w. Check it now. And if this is what alpha w, so I can say this drag component I can take this side. Okay, this side you divide this two component of drag. One drag will be here, which is nothing but drag cos alpha w, and one will be perpendicular, which is nothing but drag c sine alpha w. You please write it properly. This is because this is the drag, so two component, this alpha w, because this is the alpha w, so here it is also alpha w. You take sine and cos component. Similarly, you talk about the lift force also. You also have to resolve this lift force in two component. So check, this is alpha w here. Okay, and see, so this should also be alpha w. Check it, this should also be alpha w. Agree with me? Because see, this is alpha w, so this, because only this d cos alpha w and d sin alpha w is just perpendicular. Similarly, lift and drag are perpendicular. So if d cos alpha w and d, it is alpha w, so definitely this should also be alpha w. There should not be any confusion. So now this L, which is the lift component, I can resolve here. So two component of lift will be there, which is nothing but this side and this in a vertical direction as well. So in vertical direction, it will be lift cos component, and this side it will be lift L sine alpha w. This side, this component. Okay, and here this component will be lift L cos alpha w. I hope it is very clear to all. This is the one thing. Now, because if you see the, because you are going to write the moment about the CG, only one thing is what you are going to find, moment about CG. So where is the CG? CG is here only. So see what forces are going to give the moment. Check, very important. This d cos alpha w will not give any moment, because the line will be same, action line will be same. Similarly, L sin alpha w will not going to give any moment, because this line is what not I mean okay, that if I say that, it will not be correct, because CG is what lying here, so it is at some height, so it will give moment. Sorry, not it is not like that, it is not going to give the moment, but due to some other reason, this component will be neglecting. I will tell you, because for a small angle uh, and drag is what suppose negligible, so you can neglect that. But you see all the forces, d sin alpha w, alpha cos L cos alpha w here, d sin alpha w, L sin alpha w, d cos alpha w. For this d cos alpha w, check, for d cos alpha w and L sin alpha w, what is the perpendicular distance? That is nothing but ZC. Yeah? Similarly, d sin alpha w and L cos alpha w, what is the perpendicular distance? This one, from CG to this. What is this location? Check, everybody. See this location. Can you say this location is nothing but HC? or h minus h AC in fraction of c. See everybody, the whole length is what? HC. H is the location of CG. HAC is the aerodynamic center. So you can say H minus HAC will be this length, this colored length. This will be the length for the d sine alpha w, perpendicular length for d sine alpha w and L cos alpha w. So I think whatever the component, whatever the all the component and along x and y, all I have explained here. Now directly I will write the moment, okay, about the CG. So if you take, because okay, see, still if you have any doubt, so again we can take the separate diagram. If it is clear, then directly equation I can write. It is clear to everybody? Say yes or no. Tell me, it is clear or not? Say.
Yes, sir.
Right, right.
Yes, sir.
Very good. So I will write that. Yes. Okay. So I will write. You see the diagram now, and I am writing the equation and just cross check. Okay. I will write taking moment about CG. See everybody, huh? So okay, in short, I will show you. This is what aerodynamic center. This point. So here aerodynamic center, how many forces are there that I have to show? At aerodynamic center, I can say these are the forces. Check. In your diagram, you please focus. You will understand. This is d cos alpha w. This is L sine. Check your diagram previously. This was the L cos alpha w. It was d sine alpha w. And CG is what? Somewhere here. See, this is what CG location. So from this height was ZC, and this perpendicular distance what? H minus HAC, not HAC minus. H minus AC. बस हो गया, इतना ही है, कुछ नहीं है सर. ठीक है. Now taking moment about CG, this is what the, and at aerodynamic center also we have taken one moment which is called moment about aerodynamic center, that already I have defined. It was MAC. Yes. So now if I am writing the taking moment about CG, so you can write taking moment about CG is nothing but MCG. First MAC, you are taking moment about aerodynamic center which is clockwise, so it is already there. MAC is nothing but moment about aerodynamic center. Okay, moment about AC, and then all forces you have to take. So what I can take, see, two forces are along, I mean perpendicular, so I can take L cos alpha W plus D sine alpha W, which is giving clockwise moment about CG. You please check. So plus into perpendicular distance. What is the perpendicular distance? You can say it is HC minus HAC into C. C is the fraction distance, okay, of chord line. This is the one. This L sine alpha will also give the clockwise moment. So I can take L sine alpha W, but what is the perpendicular distance? C, Z. Z is the perpendicular distance in percentage of chord C. D cos alpha W, if you see, it is giving the anti-clockwise moment about CG, so it will be D cos alpha W into, say, ZC. Right? This is the whole equation. I hope it is very clear and all understood, because if you go in book and you see it, so much things are available. So I have tried my level best to make it short and simple. Okay, so anyway, this is done. Some assumptions you have, which is mathematical assumption, you can take that assumption and use here, so that your equation will be more shortened here. Okay, so what assumption you can take? You can say, obviously, each and every analysis whatever you are having, you can say for a small angle of attack. So say if there is the small angle of attack, so you know few assumptions. If angle of attack alpha is very small, a small angle of attack, alpha w. Alpha w is small, so cos alpha w. Alpha w is small means just say approaching to 0. So cos 0 is what? 1. So cos alpha w becomes 1. Similarly, if you see sin alpha w, so if alpha w is what? Very small, approaching to 0. So what is the sin 0? It's I mean sin alpha w. You can say alpha w is what? Approaching to 0. So sin 0 is what? 0, right? So wherever sin alpha is there, you can put 0. Wherever cos alpha w is there, you can take 1. And that always remember. Okay, you just let me this. Otherwise, sin and cos everywhere it is there. Just let me correct. If there is the small angle of attack or a small angle, so sin alpha w is almost tan alpha w, and this is approximate to alpha w. It doesn't matter exactly, it is not 0, it is approaching towards 0, correct? If angle of attack is 0, so definitely it means everywhere alpha will be 0. So in final result, alpha consideration will not be there. So better you can say it is small but not 0. So as you know, if it is small, so sin alpha w, you can write tan alpha w, and it is approximate to alpha w. If alpha w is 0 exactly, then you can take it 0. If it is there, then you can keep in your final result or in your expression anyway. So I'm taking alpha w. Okay, you cannot neglect it. So this is the one thing. Now keep everywhere, and the final result I want. So if you check the final result, what you have MCs, you please check. Hardly 5 minutes I will take. I will continue this. So MAC plus L cos. So a cos alpha becomes 1. So it becomes L D, and D sin alpha W. So sin alpha W becomes alpha W. So D alpha W. Okay. And here in the bracket, you can say HC minus HACC. This is the percentage of chord. Plus similarly Z lift, if you check, then there is the lift component, which is nothing but sin L sin alpha. You see the previous equation. So L sin alpha W. So alpha W sin alpha W, you can write alpha W. So L alpha W minus that is the perpendicular distance ZC minus D cos alpha W. So alpha W is small, so cos alpha becomes 1. So D only you will have D into ZC. These are the final result. Now small one more assumptions you can say. We can take one more assumption, so it will be more shortened. You can say D drag is what? Very small. Drag, you are saying it is small only. So if it is small, so and definitely that Z, you can say that also is small. So that value, if it is small, so you can neglect this part. Alpha W is already small, but drag also you are considering small. You cannot say 0. Drag 0 is not possible, but it is small, and alpha W is small. So two quantity both are small. So small into small, more bigger is smaller actually. Okay, so it will be 0. This whole, I should say, this whole I'm talking about. Okay, not drag, not only drag, I should say. I should be very correct, otherwise you may say later on sir has said drag is what? 0. So drag cannot be 0. D alpha W must be 0. Okay, I will write D alpha W is what? 0. Then Z, obviously here Z is that length which is very small, drag is also small, so this part again also it is gone. Okay, Z is very small, so this part, even though L is there, alpha W is small, but ZC is also small, so this part also gone. So finally the final result what you got, that is very important. MCC is equal to MAC. Okay, plus of L HC minus HAC into C. This is the result you got today, and I'm sure everybody understood all the expression here. From next class onward, I will try to short the expression or equation as much as possible. Derivation is not important at all, but yes, few up to few level you should know the derivation also. So that's all.